Yes, so good morning to all of you. So please go through the definitions given here, right? We know that FQ denotes the field with Q elements. Is there any doubt in this? Finite field with Q element. So some others denote as GFQ, means Galois field. C is for code, right? Generally we take non-empty set. Code is actually subset of FQ power n, right? Yeah. So means FQ cross FQ n times. So now a code is said to be orthogonal, okay, if C contained in C perp. Okay. What is C perp? It is a complement, orthogonal complement of C, and is said to be self-dual if C equal to C perp. What is C perp? All the vectors which are orthogonal to each and every vector in C. Yeah. So given a minimum distance, error correcting capability, one aims to construct a code of largest possible size, right? It turns out that it's very difficult problem. The largest possible size of a code in FQ power n with minimum distance d denoted AQ and D. Okay, yeah. So and the last one I want to recall you is that, for example, you have a code C, right? With NKD linear code, which is the parity check matrix, then any d minus 1 columns, if d is the distance of the code, then any d minus 1 columns of which are linearly independent, and there exists a set of d columns of which are linearly dependent. So the parity check matrix will help you that what is the distance. Distance is d, means d minus 1 columns of which are linearly independent, but any set, any d minus 1 columns, but there exists a d columns of which is linearly dependent. Okay, if all the d columns of which are linearly independent, then again rank the distance greater than or equal to d, right? Okay, so let us solve some problems one after another, go slowly. So those who are even new also, they can understand, it's not a problem. Okay, so first thing is that these are the questions, right? So go through the questions, first 3 questions, and try to tell me. Okay, I'll pause a little. Yeah, go through it and tell me. See, first of all, I'll tell you one after the another. So the elements here are, if you look at these elements, here are from the field F2. F2 is a binary, so binary code. So element digits are taken from 0 and 1, but the length of each one is 3. So it is so yeah, okay. So it is from F2 power 3. So C is subset of F2 power 3. Okay, that part is okay. So this is what we call n. N is equal to 3, right? And why it is not linear? Yeah, Sonali, why it is not linear? Linear means what? Yeah, Suresh. Yeah, Mehak, why it is not linear?
Because the weight of the code is not equals to the distance.
Yes, please repeat.
So because the weight of the code is not equals to the minimum distance.
Okay, that is one thing. Okay, but what is the minimum distance? I don't know, right? What do you mean by linear, Mehak? When we say that a code is linear code, hmm? Mehak, when you say that the code is linear code, that means sufficient for me. Tell me first that. What do you mean by code is a linear code? Any one of you? No? Mehak, what happened? You know, right? Linear code means. You don't know? Hello, Mehak.
So it is some subset of Fn.
Not just subset, no. Subset code, that is a definition of a code. But what is a linear code means? Linear code means a subspace. Okay. Why it is not a subspace? Rutuja, why it is not a subspace? So you know vector spaces, subspaces, right? Okay, I think you may be facing problem with that. Then there is, I don't know exactly where you are facing problem. It is not a subspace because why it is not a subspace to f to power 3? Suresh?
Sir, some of these two initial vectors are not in this C.
Okay, that is one way. So the, for example, some of these two is not here. Yeah, that is very good. But there is a simple approach. Yeah, this is you answered already. So it is not a subspace. Some of these two is not there. But is there a simple way? Every subspace contains one vector. What is that vector?
Zero vector.
That is not there. Sufficient, na?
Yes, sir.
So it's not linear. Okay. So this part is okay. What is the distance? What is the distance between these two?
2.
2. What is the distance between these two?
2.
2, right? So these two also 2 and these two also 2. And in fact, this with anyone is 2. So what is the distance of the code finally? Do you have any two vectors whose distance is 1?
No.
No, right? Distance is 0? No. Why 0 is not there? Because there is no vectors repeated. All are distinct vectors. So distance is at least 2 now. So in fact, the minimum distance 2 is also there. So distance of the code is equal to 2. I don't think there is any problem now. Is it okay, Kaustav? Now onwards it is clear. Distance is clear? Not clear. Distance is the minimum out of all the distances, minimum. That is called distance of the code. That is equal to 2. Yeah. What is the cardinality of C? How many vectors are there? So that is simple. 1, 2, 3, 4. 4 are there, right? So is it equal to 2 power some number? So what is singleton bound? Singleton bound says that m is less than or equal to, you remember? M is less than or equal to, so q power, yeah, C is the cardinal, m is the cardinality of C, less than or equal to n minus p plus 1, right? What is n in this problem? Yeah, n is equal to 3, d is equal to 2, right? If I say, then you will not get anything, right? Okay, so now what is n minus d plus 1, right? That is equal to 2. So it is with equality it is happened. Are there any questions at least now? Hello, is it clear? Sonali, is it clear?
Yes, sir.
This problem is completed. So I am repeating, this is not linear code because zero vector is not there or sum of two vectors is not here. Distance, minimum distance of all the vectors is 2. Singleton bound means actually, so a singleton bound is defined as C is any code with the parameters nkd, right? So nkd, then m is less than or equal to q power n minus p plus 1. This is the formula, right? So now, so that is equal to happen here. So all of them are done. Okay. Okay. I hope this is clear to you. Now I'll go to the next question. So that weight function on f2 power n satisfies triangle inequality. What is that means? What is that I have to show? So W2, W of u plus v, W of u plus v is less than or equal to W of v in particular weight function. Yeah, weight, I'll write weight. Weight of u plus v is less than or equal to weight of u plus weight of v. Yeah. So can you how to prove it? Now there is no code and all, only f2 power n. I took weight function. Okay. To help you, for example, my n is equal to 2, right? If n is equal to 2, then f2 power 2 is nothing but, actually I need to write open, like I told you this, I will not write like this, ordered pairs, right? I'll simply write 0, 0, right? It f2 cross f2. So it is 0, 0, 0, 0, 0, 1, right? 1, 0, 1, 1. Okay. What is the weight of this vector? 1. Weight means number of non-zero elements. Weight is 1. Again, weight is 2 here. Weight is 0 here. Okay. So we need to prove that weight satisfies this property. There is no coding theory here at all, since only weight is defined, that much only. Yeah. How do you prove it? Okay. So for that, so to prove this part, it will helpful to you. Is it the distance of x plus z comma y plus z is equal to distance of x comma y? Is it correct? Yes. Distance of x plus z comma y plus z equal distance of x comma y. Right? It is easy to see, right? I'm adding, for example, what is the distance between these two? And I'm adding this vector to both of them. Again, distance will not change, right? So, so by using this, we can prove this easily. Okay. So how do you prove that? So I'm writing here. Okay. So I'm writing here. See, weight of u plus v is equal to, how do you write in terms of distance? Weight of u plus v equal to, any one of you can tell? Weight of u plus v equal to distance of u plus v comma, yes,
0.
0 vector, right? Yeah, so 0 vector. But distance satisfies triangle inequality, that we proved. But anyhow, let me write one more here. So now, can I add this here? These two are same or not? So I told here, right? Distance of xy is equal to distance of x plus z comma y plus z. What is that I added here? V I added, right? Now it is equal to distance of u comma v. Why? Can somebody tell me why v plus v becomes 0? Yeah, if you look at these vectors, right? You take any vectors here, if you add it to itself, what happens? Huh? What is 0? Add to this, 0 plus 0 is 0. 1 plus 1 is 0, right? Are you following? Hello? Yeah, right? So if you add to itself, then it becomes 0 vector, right? So this become v plus v becomes 0, right? It is uv. But now you know that the distance function satisfies triangle inequality. So it is distance of u comma 0 plus distance of 0 comma v, correct? So this is nothing but wt of x u plus wt of v. So is it okay? Back, is it the part is okay and clear?
Yes, sir.
Yeah. Okay. So I hope you understand second question, all of you. Do you need anyone has any problems? Let me know. Pratik, are you clear? No?
Yes, sir.
Do you know how to prove this? Nothing. See, what is it I am adding? I am adding Z to both of them. No? Adding means, so you understand right here. For example, I take these two vectors. I will add 0, 0, 1 to both of them. What I will get? Okay. So 1, 0, 0 and 0, 1, 0. For both of them, I am adding 0, 0, 1. What I am going to get? Yeah? 1, 0, 1, 0, 1, 1. Right? Now earlier distance is 2. Now also distance is 2. There is no change. Okay, that can be proved rigorously also. Okay? That is the only thing I am using. Okay, now concentrate. Right? Now concentrate well, so that you can understand much better. Look at this question and try to answer things. So, what is n value, k value, d value? D may be little difficult. You can tell, and n, k you can tell easily. Yeah. Can you tell someone, one of you? Third problem.
7 and 4.
N is
7.
7. K value
4.
4. How do you know that?
So the matrix is 7 cross 4.
Yeah, 4 cross 7. Yes. So matrix is 4 cross 7. Generator matrix G is of the size K cross N. No, simple, nothing. So I hope you will remember in future also. Generator matrix is given. Number of rows is called K. Yeah. How can you forget that? You cannot forget, right? So a number of columns equal to N. That is 7, right? So okay. So this part is clear to all of you. Yeah. Next one is that what is the cardinality of C, right? So for linear code, what is the cardinality? Linear code, what is the cardinality? Yeah. What is the cardinality of linear code? So it depends on K. K is the dimension of the code. K is the dimension of the code, right? So first of all, tell me that C is subset of what? Code is subset of which set? Do fast now. Please tell me fast. Hello? Please respond here. C is subset of F2 power n. Na? What is n? N already I told 7. It is F2 power 7, correct? Okay, so this is one code word. This is another code word. This is another code word, right? So these are code words, but these are the only all linear combinations of them also code words. So are they linearly independent? These four are linearly independent. Hello?
Yes, sir.
Yeah, so they are linearly independent. Because of that, what is the dimension of the code now? Dimension of the code is 4. So basis is for these 4 vectors. So cardinality of C is equal to 2 power k. This is in general. You know k value. So cardinality is 2 power k. So what is the answer now? ये भी बताना है. K is equal to 4 है. So 2 power 4. 2 power 4 value पता है आपको? वो भी पता नहीं? Okay. It is 2 into 2 into 2 into 2. Okay. 2 2s 4. Okay. And these 2 2s and 2 into 2 also 4. 4 into 4, you know, I hope. It is 16. Yeah. You have to respond. I'm not able to understand. Okay. So what is R means? R is the rate of the code. Rate of the code is defined as rate of the code equal to K by N. What is the K value? Can you tell at least now? What is the rate of the code?
4 by 7.
Yeah, 4 by 7. Rate of the code is 4 by 7. Okay. So this is done. Okay. So n value is 7, k value is 4, cardinality is 2 power k, so 16, right? And r equal to 4 by 7. Okay. So these are done, right? Now list all the vectors. So what are all vectors? All the vectors, how do you get it? So what is the target it? So I take 0, 0, 0, 0. All 4 vectors you take it. Okay. I'll write here. Okay, what is that you have to do? So take 0, 0, 0, 0. Multiply it to g this side. Okay. So 0, 0, 0, 0. So this into this, okay, as a column, this into this is 0, this into this is 0, this into this is 0, like that, right? So actually you are adding it. What is the meaning of 0, 1, 1, 0 means? Can you tell somebody? This into 0 into this plus, right? So actually we are adding things, okay? We are adding these two rows, okay? That's what we're going to get. So can you tell me somebody what is this equal to? Yeah. So is it not clear to you?
Sir, I didn't understand the question.
No, multiply, ma. You know how to multiply two vectors. Matrices you multiply. How do you know? What is 1, 2, 3 into A, B, C, D, E, F? You know this, how to multiply?
Yes,
Matrices multiplication. Yeah, multiply it.
yes.
What? 1. So not here. This is not correct. So it is 1, 2. Okay. So how do you multiply? What is the answer to this? Can you tell me? Now tell me, na? Not clear. It is a matrix. No. Matrix multiplication. Ji. It is 1 by 2, right? It is 2 by 3. So I'm going to get 2 by 3, 1 by 3. What is that? Can you tell me?
A plus
No. A
A
plus,
plus 2D,
yeah.
B plus 2E,
Hmm.
and C plus 2F.
Right, like that, right? Like that, what is this 0, 0, 0, 1, 1, 0, 2 into this matrix, right?
Okay, sir.
That is the way we done actually. We defined it.
This is 0, 1, 1, 0, 0, 1, 1.
Yeah, so sorry, 0,
1, 1, 0, 0, 1, 1.
0, 0, 1, 1. Okay, so let us see. So this is 0 clear. This is 0 clear. Now here I'm getting 1 clear. Here I'm getting 0. Here I'm getting, how I'm getting 1 here? You told 0, 1, 1, right?
Sir, fourth is 0. Third one is 1, 0. First 0, 1. Then
This
1.
is multiplied to this, right? So 0 into 0 plus 1 into 0 plus 1 into 1. Okay. 1 into 1 is 1, correct. So this is 1, correct. Right? And here it is 0, correct. Why here it is 0? Because 1 plus 1, 2 is coming, so 0, correct. So you are understood, correct. So you understand? So like that, what is that I am doing? So, so can you tell me that what is the vector I have to multiply here so that I'll get the first row? Are you following? What is that I have to multiply to get the first row? Not clear. What is this if I multiply?
First row.
You'll get first row, right? What if I multiply 0, 1, 0, 0?
Second row.
Second row, right? And like that, you'll get, no? So 0, 0, 0, 1 into G, I'll get all the 4 rows, right? What I will multiply 0, 0, 0, 0, I'll get 0, 0 row, right? So like that, how many vectors are there? What is the last vector? 1, 1, 1, 1, right? So total, how many vectors are possible here I have to multiply? How many vectors are possible here? 0, 0, 0 to 1, 1, 1. How many are possible? Please say.
16.
16. So if I multiply each of with these things, I'll get different vectors, right? Row vectors. Okay. So this will give 0, 0 vector. But what is the which vector I'll get? 0, 0, 0, 0. Can you tell me here? What is it I get? 0, 0. What is the length? 7, right? Okay, are you following? 4 I am multiplying, but 4 by 1 by 4 into 4 by 7. I'm getting 1 by 7. 1 by 7 means 1 row, 7 columns, right? So I'll get all the vector. That is this answer. Are you able to figure out? Are you able to find out later? Hello?
Yes, sir.
Total, how many vectors are there? 16 vectors are there. Each of length 7. Okay. If you multiply 100, I'll get first row. So C contains 4 rows also and more than that. So it is a linear code. So is it okay? Now generator matrix is given. How to find all the code vectors? You can find all code vectors. Take K. K value is how much? 4. So now take all the possible binary vectors of length 4. Multiply to G. Okay. So how many are there? 16 are there. So I'll get 16 vectors. Okay. So G is a map. G is converting. G is a map from where to where? G is a taking vector from where? F to power 4. Taking to where?
F to 7.
F to 7. Yeah, this much only. Right? It is 1-1 map because the rows are linearly independent. So here these are all distinct. We are going to get distinct vectors. So, but they are of length 7. That is this C. Yeah. So I hope now this is clear to you, right? Any questions now? You can ask me now. Is how to, can you list all the vectors now in future also? Yeah, I'm deleted. Okay. Any questions you can ask me. Please ask. Without asking how it is possible, right? Whether you understand or not, how do I know? So, Kaustubh, is it everything clear? Okay, Kaustubh is not here. Sonali, is it everything clear?
Yes, sir.
Mahek?
Yes, sir.
Okay. So, Pratik, you know these two answers now by this time?
Yes, sir.
N value, K value, cardinality of C, R, rate of the code, list all the vectors, right?
Yes, sir.
Okay, now how to find D? To find D, I'll find corresponding to this, there is something called parity check matrix. What is the parity check matrix? How it is defined? You remember? So if G is equal to identity, you see that here identity is there, right? It is I4, correct? I4 cross. So it is written, when matrix in this form, first identity and then that is called systematic form. Okay? That is called systematic form. Okay, so it is of the form IK. K, what is K? K4, right? IK, 4 cross 4 and matrix A. Then H becomes minus A transpose I n minus K. So this is now, what is size of A? What is size of A? Please little faster. Huh?
4 cross 3.
Yeah, 4 cross 3, right? What is 3? 3 is n minus K, correct? Right? These are 4, right? These are 4 columns, so n minus 3. Yeah. So now what is the size of this one now? It is 3 cross A transpose, 3 cross 4. So that means 4 columns. But this one, What is the size of this one? 3 cross
3 cross 3.
3 cross 3. So 3 cross 4, and so total that will get like that. So I'll now write that matrix. Okay. But what is minus A transpose in binary? What is minus means there is no
A
minus.
transpose.
A transpose only, right? So now I write like that. So this is my A, right? This part is A, but I'm writing into A transpose. So first I'll get 0. Now this column becomes row here, correct? So it becomes my H is equal to, so first 0, 1, 1, 1, right? This one I'm putting as a row, right? And 1, 0, 1, 1, yeah, 1, 1, 0, 1, and identity matrix here, right? So is it Pratik, is it clear how to construct H from G?
Yes, sir.
Okay. What is the size of this matrix now?
3 cross 7.
3 cross 7. What is 3?
N minus K.
So in general, my G is, I told you it is K cross N in general, right? What is H size? N minus K cross
K. N.
N. So G is K cross N, H is also, columns are same. Okay, both the ways columns are same. So code is code, this code C. Okay, code comes in 2 ways. One is that to multiply the 4 length vectors this side, or otherwise find the null space of this. Okay. So for example, we'll check with one example so that it will be easy for you, right? So for this vector, for this matrix, so second row is a row vector. It is in the code, right? I'll multiply here 0, 1, 0, 0, 1, 0, 1. Okay, this I took this row. Yeah, what is that I'll get if I multiply this into this? Can somebody tell me? So this is actually 3 by 7, and it is 7 by 1, right? 7 by 1. So I'll get 3 by 1, right? Are you following? So this is 7 by 1. So I'll get 3 by 1, right? So 3 rows and 1 column, right? And what is that I'll get? Multiply it and tell me.
0, 0, 0.
We'll get 0, 0, 0 because it is in the null space. So that is another way to find out. Find all null space exactly C. C can be found in 2 ways. One is that multiply or take any 4 0 vector, multiply here or find null space of this. Yeah. Okay, fine. So please check those things later. Okay, now I want to find the distance. So right, I want to find the distances. Correct? Distance of the code. But you remember I gave one thing in the beginning. What is I gave? So here I told, right? So any d minus 1 columns are distance is become d if d minus 1 columns are linearly independent, right? So if and there exist d columns which are linearly dependent, then we'll say that the distance is d. So look at the columns here. This is the first column, second column, like that. We have 7 columns. Is it each column is independent? Single vector. Is 0, 1, 1 is independent? Hello? You know, right? A single vector is linearly independent or not?
Yes, sir.
Why it is independent? Single vector is independent because
Because 0 or 1 is there, so multiply with 0, we will get 0, and multiply with 1, we will get same vector this.
Okay.
So,
Actually, any non-zero vector is always linearly independent. No? Single non-zero vector is always linearly independent, right? So one vectors are, so if you take any one column, that is linearly independent. That's why distance is greater than 1. Okay. Now if I take two columns, are they linearly independent? Here if I take two columns, these two columns are independent or not?
Yes, sir.
Yeah, because I'm not getting the second vector from first by multiplying by 1. These are, here I told you several times, I'm repeating one more. The binary vectors, two vectors are dependent only if they are equal. All of them are distinct. So any two columns, if I take here, they are, if I take any two columns in this matrix H, they are linearly independent. So now distance is greater than 2. Now, is it three vectors also linearly independent here? Is the three vectors, if I do you find three vectors, they are linearly dependent? What is the sum of these two? Hello?
1, 1, 0.
0.
Right. So I'm getting this vector. That means these are not linearly independent. They are linearly dependent. So that means if I take any two columns, they are linearly independent. But if I take three columns, there are three columns which are linearly dependent. That means distance of the chord equal to 3. Pratik, now you can ask. Or you can find directly. You found all the vectors and find the distances. That is much complicated, right? Okay. Any other questions? Okay. Now the next question is that find all possible weights of code words. So something is a problem. So these are the mistake, weights of code words. Yeah. So can you figure out that? See how many vectors are there in C? Huh? How many vectors are there in C?
16.
16, right? Yeah. So can you have one vector whose weight is 0?
0, 0, 0.
Yeah, it is there now. So we have weight 0 vectors, right? 1, 0 is there. Can you have a vector of weight 1? Can I have? See, you do not know what are 16 vectors, right? You are not listed. But even then you can comment. That's a great. Okay. So it is a linear code. In the linear code, okay. So linear code, distance of the code equal to what? In terms of weights. Do you remember that? Hmm? So you take all non-zero code words and take their weights. Out of all of them, the smallest is called the distance. Right? In the linear code, that happens. Okay. Are you following?
Yes, sir.
What is that I want to say? So let us look at this example. One example I'll give you. So Give one example. So let us take 0, 0, 0, 1, 0, 1, 0, 1, 1, right? 1, 1, 0, right? What is it a linear code? Yes. How it is, why it is a linear code? So it comes from this generator matrix. What is generator matrix? So 1, 0, 1, 0, 1, 1. Okay. So you multiply 0, 0 to this, right? I'll get the first vector. Okay. If I multiply 0, 1, I'll get the this vector. If I multiply 1, 0, I'll get this vector. If I multiply 1, 1, I'll get the last other vector, right? Like that you can work out. It is a linear code. So what is the distance of this? What is the distance of the code? Means out of all the, we need to see the distances, different vectors distances, and we will take the minimum. But linear code, that is not, it is a simple way. Find the weight of this vector, weight of this vector, and weight of this vector. And the minimum you take. What is the weight of this code? What is the distance of this code?
2.
Yes, please.
2.
2, right? Because weight for all of them is 2 in this case, right? So that is what weight means. Okay. So weight for all of them is 2 only there. Okay. Like that. Now already I know the distance is 3. So that means what is the minimum weight for non-zero vector?
3.
3, right? So you cannot get weights. There is no vector here whose weight equal to 1. 1 is not possible, right? 2 is also not possible. Are you following that part? Right? Minimum distance is 3, meaning there are no vectors of weight 1. If there is a vector of weight 1, then minimum distance become 1. Okay. Yeah. So, but can you have vector of weight 3? Do you have vector of weight 3? Can you give one vector of weight 3 in this code?
Yes, sir. It's 1, 0, 0, 0, 1, 1.
Yeah, the first row, right? First row, these are also part of here, right? So we have weights 3. Can I now the question coming? So what are other weights? What is the maximum possible weight I can have?
7.
7. Very good. Nice. Thank you. So 7 is a maximum because all ones. Is it belong to that? That's why I asked this question. Is all ones belong to C? Without, I'm not computed all the vectors, 16 vectors, right? You can compute. You can answer all these questions, but we want to do without actually computing. So that's the idea, right? Yeah. So can somebody tell me that is it there? Is I'm
Yes,
asking,
sir.
how can you show 1 1 1 1 1 is there? Yeah, good, very good. Your answer is correct. Can you prove?
So we just know that the possible weights which we have will be 7, the maximum. So according to that logic, 1, 1, 1, 1 will be there in C.
No, no, no. It is not like that. See, so 0 0 0 0 1 1 1 0 1 1 1 1 0, right? Yeah. What are the weights in here? 0 and 2 only. This weight is 0. So what is the maximum weight for a code? In f2 power 3. So here I already listed. So everyone weight is 2, weight is 2, weight is 2, weight is 0. You already know. So, but what is the maximum possible weight a vector can have in general? 3 only, right? If all of them are 1 1 1, then only it is. But 1 1 1 is here. No, right? It need not be here. Okay, we need to show it whether it is, we need to figure out whether it is there or not. Yeah.
Okay, sir.
So can you add all these rows here? Add all these 1 plus 0 plus 0 plus 0. 1, right? 1 here, 1 here, 1 here. What is this sum?
1.
1, 1, 1. So it is, I told that it is a vector space. Vector space means sum will be there. So it is there. Okay. Yeah. So this is there, right? So now, so I came to know now this is also there in C, right? That means these are 4 vectors. Now I know that, see, some of these two also will be there. Try to understand. These two, all possible additions are there, right? Okay, right. That is what we are doing when you are multiplying by 1, 1, 1, 0. Matlab kya hai? I am adding these two vectors, right? That is the meaning of that. See how to add all of them, right? So I had to add these two, I had to add these three, I had to add this and this, I had to add this and this. So that is exactly what we are doing. For example, I want to add these two vectors. What is that I am doing? So these two I am making 0, right? So this into 1 into this plus 0 into this plus 0 into this plus 1 into this, right? That is what I'm multiplying by this vector. Are you following? Is it okay, my head? Yeah. Okay, good. Now these two are, this is also now in C. So now what about this plus this first vector? Is it also in C? Hello? This plus this first vector is also in C? What is the problem you are facing? It is a vector space, ना? Vector space में 2 vectors है तो उनका sum भी होगा. क्यों दिक्कत हो गया आपको? Okay. So what is sum of these two vectors? This vector and this vector.
1, 1, 1, 0, 0, 0.
So that is also in C now. Okay. Now I am asking you a question. So now understand this. What are the possible weights, right? I am looking. So 0 is there, 3 is there, right? So can 7 is there, right? We already saw 7 is also there. Can I have 6? Question mark. Can I have 6? Okay. Suppose there is a vector whose weight equal to 6. What is the meaning of that? Please respond here. For example, you have a code word whose weight equal to 6. What is the meaning of that?
It have 6 non-zeros element.
What are but it is binary. So how many? What are those non-zeros?
Ones.
So that means that code word contain 6 ones, right? Right. Now that I added to this, now I'll add that to this, right? That also need to be there, right? Now, what is it? If I add that vector to this vector, what happens?
That will be 1, 1 only. So
One,
it
one,
will
one.
not be possible.
Very good. See, because distance is 3, I cannot have weights 1, right? So this is not possible. We are found very intelligently without actually computing. See that? Can I have 5 also? Can I have 5?
No, sir.
No, it is also not possible. Can I have 4? Yes, because already vector 3 is there. So 3 plus 7 is 4. So these are there. So what are all possible weights now? So possible weights are 0, 3, 4, 7 only. There are no vectors of weight 2, weight weight 1, weight 2, and so weight 5 and weight 6 because of the 7. 7 is making the possibilities nicely. Okay, good, nice. Any questions now? So we already computed parity check matrix. CPERP is the, how do you find CPERP? So at least one time I will tell you. So you know that what is the H, right? I'm again writing one more time. So can you tell me fastly now? I'll write here somewhere. So please calculate C in your notebook and let me know fast. Oh, sorry. Yeah, so yeah, tell me parity check matrix H fast.
0 1 1.
First row,
Yes, sir. First column.
first column 0, 1, 1. Okay,
1 0 1
1, 0,
1 1 0
1, 1, 0,
1 1 1
1, 1, 1.
and 3 cross 3 identity matrix.
Very good. Nice. Okay, yeah. So now what is CPERP means? CPERP is actually for this matrix that CPERP is generator matrix for CPERP is this. Generating matrix for CPERP is this. Okay, but how do you find all the vectors? How, what is the cardinality of CPERP now? Now think of this is your G. Okay, so think this is your G, right? Now what is a K value, what is N value, and what is CPERP? So if you understand till now, then you can tell this also. Here you told cardinality of G, cardinality of C. Can you tell me what is the cardinality of CPERP? Yeah, please first.
8.
Huh? Yes.
8.
8, correct, 100%. Because now this is my G, so size of this matrix is 3 by 7. So 2 power 3, 2 power K. Okay, now I'm calling it as K instead of N minus K. Now for this code, CPERP, this becomes the parity generator matrix. Now this becomes G for this. This is H for that. Now this becomes parity check matrix for CPERP. G becomes H for this CPERP. Role changes, okay? Okay, how to find all the code words now in CPERP? Yeah, can you tell me? How do you find all code words in CPERP? 8 are there, right? What is that I have to multiply? To what? If you understand till now. Yeah, please fast. What are all vectors in CPERP, right? How CPERP look like? CPERP look like, this is my generating matrix now, right? So into something, right? So how C look like? C is equal to VG, right? Such that V belongs to where? You forgot that. Where V belongs to?
F to 4.
F24, correct. So F24, I'm changing all the vectors, I'm multiplying to G, and I'll get all the vectors, right? In CPERP,
Multiply with F to 3.
F23, very good. Okay, so very nice actually. This is simple, right? So how do you find? So you are not finding, na? So at least I'll find one for at least once. Okay, in future I think you will figure out this. Okay, so 0 0 0 multiply to H. Okay, I'll get 0 0 0 7 vector. Okay, 1 0 0 multiply to H. Okay, 0 1 1 0 0 1. So 0 0 1 multiply to H. What are you going to get? Last row, right? It is okay. 0 1 0 1 0 into H. What I'm going to get? Second row. 1 0 0 into H. I'll get first row, right? So now what is that? 1 1 1 0 will give me. What is that? 1 1 0 into H will give me. Yes, tell me what is that will give me. No?
1100.
No need to tell that answer, okay? What is that it is doing?
It's
It is
just adding up.
some of these
Just
two
a second.
rows, okay? It is some of these two rows. Are you following that part? What is this 001 is giving? You check that? 0001. So 00 into this, 0001 into this. What is problem to you? I'm not able to see that. This is last, this is gives the last row. So if these two are there, then this is actually sum of the first two rows. Okay. What are the 011 will give me?
Sum of last two rows.
What is the 111 into H will give me?
Sum of all the three rows.
All the three rows, like that. Nothing. Actually, if see, C-perp is actually linear combination of these vectors. So I'm doing all those linear combinations. That is the thing I'm telling. Okay. Right. Okay. So what is MDS code means no? You understand what is C-perp? What is MDS code? Okay, then figure out. So try to find what is MDS code, perfect code. Okay. The following is the parity check matrix for NK code. Okay. I already gave that it is a parity check matrix, right? For NK code. Can you tell me what is N value and K value? But I'm telling you is a parity check matrix, not generator matrix.
5 and 2.
N equal to 5 and K equal to 2. Very good. What is G? You know that this is comes from G by doing A transpose into identity, correct? You know that. So now this is size of this matrix is what? You remember that? We tell fast here.
2 cross 5.
This is 2 cross 5. So 2 rows will be there and 3 columns will be there. What are the 2 rows? Or you can tell me that way. You know, first identity matrix will come, right? You know? Yeah. So 2 by 2 identity matrix will come. So 1 0 0 1. Right? What are these two vectors? So this first column now become row, right? The second column now becomes, yeah. So this is my G. Can you find C now? How do I get C? Now be quick. I'm erasing and I'm explaining one more time, final time, right? So all of you please concentrate. See, I'm going very slow and I hope anyone can understand, I hope these things. Yeah. See, what is that I'm telling? So here n is equal to 5, k is equal to 2. Okay, because this is n minus k cross n size. Okay, so this you understood. Now what is G? G is of the size 2 cross 5. And first one is identity matrix. And this first column becomes row. Second column becomes another part. Okay, so now this is the, now what is my C? How it is C defined? It is VG such that, yeah, can you tell me where this V belongs to?
F22.
F22, right, correct, F22. Okay, what is the cardinality of C before that?
4.
4, very good. So it is 2 square, right? So this is 2 square. So it is equal to 4. What are those vectors now? Let us write down them, right? So what is that I do? So first I multiply this with So I'm writing now 00G, 01G, 10G, 11G, right? So see, try to understand that when you have a first we have identity, then I'll get ID as it is. So first we'll get these things as it is. Okay. In the length 5, but first two already I know because identity will take them to them only. So 01, 10, 11. So I'm closing here because I need to put 3 more vectors. Okay. Now, so what is that? I'll multiply 0, 0 to this. I'll get 0, 0 to 1, 0 is 0. 0, 0 to 0, 1 is 0. So all are 0. So this is 3 zeros. Are you followed this part? What is the second vector now? Tell me first. 0, 1.
Second row.
Yeah. 1. Here 1. Here 0. Here 1. Correct? Now here 1, 0. Yeah. Tell me. 1.
1,
Yes.
1, 0.
1, 1, 0. What is the last row? Last one?
1,
Yeah.
1, 0, 1, 1.
1, 1, 0.
1, 1.
1, 1. Very good. So these are the 4 vectors, right? So I hope you are understanding everything now. It is a linear code. Okay. What is the now you figure out what are the values you have. N equal to 5, k is equal to 2, and the C value you know, cardinality of C equal to 4, and you know complete C. Now can you figure out what is D value? So how do you find the distance of the code? One is that finding the distances and we find the minimum. But instead, since it is a linear code, I'll find the weights of the non-zero code words, right? These are 4 code words, but only 3 are non-zero. What is the distance? So what is the weight of this code word?
3.
3. This one 3.
3.
This
3.
one is 4. But so minimum is 3. So distance is 3. Okay, are you understand how to find the distance of the code? It is D or D of entire code. Otherwise, you found the distances. What is the distance between these two? That is exactly weight. Distance between 0, 0, this and 0, 0, this and 0, 0, these are the exactly weights. But now I no need to find these distances, right? That is the advantage of the linear code. Yeah. So distance of the code now becomes easy. Okay. Now go to the questions. So what are the questions asked? Find n and k, you asked. Find generating matrix, you found. List all code words, you find. What is the rate, code rate?
2 by 5.
2 by 5, right? Yeah, that is also you understood. So you completely done this problem, right? So take a small break and again I'll continue because you are now participating started. I will continue in a while. Yeah, so go through this question now. So question number 5. Am I audible?
Yes, sir.
Okay. See, what is that we are telling is that find 32 co-binary words. It is not possible to find 32 binary words, each of length 8 bits, such that each word differs from other by at least 3 places. Okay, so at least 3 places means what? Each word differs from every other word. At least 3 places means what? What do we know about the code? Something. Can you say?
Distance of the code is 3.
Yeah, greater than or equal to 3, right? Yes. Distance is greater than or equal to 3, right? Yeah, very good. So if distance is greater than or equal to 3, then what I can do, I can construct a code of length distance 1, right? If I take a code of distance 1, right, then how many code words will be there? If I take another code word, again another distance will be there, right? So what is that I want to say? You look at this 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 0, and 0, 1, 1, right? Okay. Now here distance is 2. Okay. But if I take a 101, okay, so I take a circle with 101 as radius, 101 as center, and radius is 1. So which vectors will be there in this circle?
No one except 101.
uh, from this code, but for example, okay, I'll take like this, right? Distance equal to 1 also I'm considering. Less than or equal to 1, think like that. Okay, so this is 101. So distance less than or equal to 1. I'm saying distance less than or equal to 1. Yeah, tell me now. Is it 101 is here? Yes, right. It is a center. And distance from 101 to 101 is 0. So that is there. Can you give me any vector which distance is less than or equal to 1? What about 100? Is it here?
Yes, sir.
Because distance between these two is
1.
1. So that is also here. But is it a code word?
No, sir.
No. So only code word which is here is 101 only. That's what you are also saying. So when distance is greater than or equal to 3, so what are the code words will be inside now? Which code word? Oh, sorry, which words will be inside? Not code words. Code word is only one, but how many words will be there? So only which words will be there? That now distance is 1.5. I'm taking 1.5 or less. Okay. Even 1, let us say 1 only. Why? Okay. If I take 1, then which vectors will be there? Which distance 1, 0, and 1 only, right? How many vectors will be there of distance 1 from any given vector? So for example, I have a vector, okay, of length 8. So I'm taking 1, 0, 1, 0, 1, 0, 1, 0, right? Can you give me one vector uh, whose distance from this is 1?
0, 0, 1, 0, 1, 0, 1, 0.
Yeah, so only one of them I'll make it to 0, right? So how many vectors are there at a distance 1 from this?
8.
8. Very good. How do you know that? First of all, you need to choose some place, and that you replace it by 0, right? If you choose this one, you replace it by 1, right? Remaining as it is, right? So like that, I can, how many places are there? 8 places. So total, how many vectors are there inside the circle now? Still not clear.
9.
9, very good. So there are total 9 will be there at most. Are you following that part? Yeah, there are 9 will be there, correct? So now, but yeah, so there are total 9 will be there in each one, right? Okay, I hope that part is clear. So now 8-bit words, right? So 8-bit words mean total how many words will be there with 8? 2 power 8. 2 power 8 equal to 256, right? Now, no two code words are within a distance 3, then that sphere of radius 1.5 about any two code words must be disjoint. So the volume of the sphere is number of points in the sphere. Within the distance 1.5, any 8-bit code word are 9 words itself, and those words differ from in it exactly 1 bit, right? So, but 256 by 9 is how much? See how many circles I need, right? That I am looking. This circle contains 9. Another circle contains 9. This is another code word. One code word. So another code word, another code word, and 999. So total how many? Yeah. So total how many circles is possible? 28 only, right? But now what is the question asked? 32 bit binary. So that is not possible. Are you following this question?
Yes, sir.
What is that I want to say? If you have 32 binary words, right? Code contains 32 out of 256. I have a code with the 32 binary words, right? I'm telling it is not possible. Why it is not possible? With now distance also greater than or equal to 3. With this, it is not possible. We are telling why it is not possible. I take these 32 code words C1, C2 up to C32, right? Now, if you draw circles around them, okay, if you draw circles around them, right, they not be exactly like this C32, C1, right? This contains 9, this contains 9, this contains 9. So total 32 into 9 is more than 256. But total number of binary words with 8 are 256 only. So that is not possible. Yeah. So I hope this part is clear. Please go through and let me know. Okay. Is it okay, all of you? Suresh, is it fine for you?
Yes, sir.
Okay, good, nice. Okay. Now, can you construct a code like this? That is the question over FQ. Okay, so let us see. What is the meaning of this? So this is actually this brackets are different. This is N, this is M, and this is D, NMD. Okay, M is the number of vectors, size, cardinality of C. Okay, can you have like this? So Q is any prime power. So let us work with the Q equal to 2, and I'll explain one case. Okay, so look at this, right? So Q equal to 2. Okay, I'm taking this 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, right. So can you tell me is any what is N here? Hello, for this code, what is N?
3.
3. What is the cardinality of C?
4.
So is it equal to Q square?
Yes, sir.
4, correct. So this is satisfied, this is satisfied. What is the distance of the code?
2.
So that is also satisfied. So for Q equal to 2, I gave. Yeah, for Q equal to 2, I gave. Now can you give for Q equal to 3? Okay, I'll tell you how I constructed it. Okay, so that it will be helpful to you. So I took these 0, 0, 0, 1, 1, 0, 1, 1 first. You see that? 0, 0, 0, 1, 1, 0, 1, 1. Can you figure out how I get this vector, last element?
By adding the previous 2.
Yeah, so 0, 0. So 0, 0, 1, 0 plus 1 is 1. 1 plus 0 is 1, like that. Now can you try for 3 now? 3, Okay, you understood, you are correct. Okay, so think of, so what is F3 first? Okay, try to understand what is F3 first, right? So that means F3 means three symbols will be there. What are those three symbols?
0, 1, and 2.
0, 1, 2. Very good. 0, 1, 2. Correct. So 0, 1, 2. Right? So 0, 1, 2. Right. So what is that I will do first? To Q square I need. Okay. So I do 0, 0, 0, 1, 0, 2. Right. 1, 0, 1, 1, 1, 2. Right. Yeah. Next one. 2, 0, 2, 0, 2, 1, 2, 2. What is that I will do next? But I want length 3. Okay, I will add them. Let us see. So tell me now, what is this value? Rutuja, what is this last value here?
0,
0. Here, 2, 0. Here,
0, and 1.
1. Right. Now, how many vectors are there total now? This is my code now. See, I not horizontally, actually comma, comma like this. So what is the cardinality of C now? 9. That is equal to 3 square. Correct. So what is the n value here? 3. Again, length is 3 only. What is my d value? Okay, so look at any vector here. So again, it is a linear code. It is a linear code. In the linear code, it is sufficient to check non-zero code words ka weights. Can I have a vector whose weight is 1 here?
No,
Hello.
sir.
Can I have a vector whose weight is 1?
No, sir.
No. So minimum weight is how much? 2. That means distance of the code is also 2. Right? Yeah. So we done it for 3 also. In general, how do you do it now? Now, in general, how do you do it? What is the procedure I am followed? For any queue now, how to do it? Right? How do you construct that C? C is equal to, can somebody help me? It is A, B, C. Yeah. I'll write as a vector so that it will be clear to you. How I constructing them. A comma, B comma. What is the last vector? Last element, the last coordinate?
A plus B.
A plus B. Okay, where A comma B belong to? See, I took first all the two vectors, I added them, right? I'm not going to get all the vectors, all 3 length vectors. Only some of them only I get, right? See, I have 0, 0, 0, 1, 1, 0, 1, 1. All binary words of length 2 are there, but only I am now getting, right? I am getting only weights of length 2, weights 2 only. I'm not getting 1, 0, 0, right? I'm not getting 4 vectors. Out of 8, I got only 4. Are you following? So like that. So this is actually, you need to check that. What is the cardinality of this set now? Because these are only varying. This is fixed already, A plus B, right? So there are Q choices for it, Q choices for it. So total Q square choices. The cardinality of FQ square, correct? And length is anyhow 3. Now only thing you need to check is 2. That is easy. Okay, distance is 2 because when I take A equal to 0, yeah, and B is non-zero, right? I'll get length 2, right? So done. Weight 2. There is a weight 2. I cannot have weight 1. Why we cannot have weight 1? Can you prove that? If you prove there is no vector of weight 1, we are done. Correct. How do you prove that? Weight 1 means what? 2 of them are 0, right? For example, so this one is this one and 0. Then when it happens, that means A is already 0. This is 0 means A is 0. And A plus B 0 means what? B also has to be 0. Then entire vector is 0. So if 2 of them are 0, entire vector is 0, right? So we cannot have weight 1 vectors. Is it okay? Yeah, we are going very slow. Is it okay, Pratik? Are you clear?
Yes, sir.
Okay. Now let's see the binary code with the block length 14 consisting of all sequences in which there are at least 3 zeros between 2 ones, and find the rate of C. Okay, I'll complete it a little faster. So I want a code of block length 14 means what? Block length 14 means n equal to 14. Okay. Find, so I am constructing the code C. What is this contains? All sequences in which there are at least 3 zeros between 2 ones. Okay. Whenever I have 1, immediately I cannot have 1. What is that I need to have next?
3 zeros.
3 zeros. Then I can have 1. Again 3 zeros. Right? No, in any number of zeros can have, but length equal to 14. I am collecting all those. What is the rate of that code? That is the question. It is not a linear code. It need not be linear code. Okay. It need not be linear code, but yeah. So that is the question. So let us work out this. So actually rate of the code is this, answer is this in general. So we need to find m now. Let mn be the number of binary sequences of length n having at least 3 zeros between 2 ones. Okay. So I'm giving the value. For example, if I take 3 to explain you this, I'll explain with this 3 case. Okay. So why here we do not have 2 ones here? Are you okay? See, 0, 0, 0 is allowed. Okay. 0, 0, 1 is allowed. 0, 1, 0 is allowed. 1, 0, 0 is allowed. Why 1, 0, 1 is not allowed?
Because there is only 1 0 between two
Yeah.
ones.
So these are the only possible with n equal to 3. Okay. N equal to, so the total 4 are there. N equal to 3, only these 2 are there. 1, 1 is missing here. You see the 1, 1 I cannot put. Between 1, 1 there are 3 zeros actually. But length itself is 2. I cannot have that. Okay. So here easy to figure out. Okay. You can see that these are the only. Okay. Whenever I have 2 ones, there is a problem coming, right? But 6 and a little complicated. 6 I can have with 2 ones also. Can you give me one code with 2 ones? Yes, right? I'll put 3 zeros right here. N equal to 4. Please try to understand. N equal to, even with 5 also I can get 1 with 2 ones. But up to 4, up to n equal to 4, I cannot get 2 ones. Okay. The exactly 1, 1 will be there, zeros are there. These are the exactly. So I can find them, all of them, right? Yeah. But how do you construct this? I am constructing it by combinatorial approach. Okay. So how do you do this? For example, first bit is 0. Now I am doing for n greater than or equal to 5. If the first bit is 0, then how many remaining vector are there? N minus 1 bits, right? That can be any valid sequence of length n minus 1, right? Right. Valid means here satisfying this condition. So then how many will be there? Mn minus 1 will be there. The first bit is 1. The first bit is 1. Then next 3 bits I have fixed already. Next 3 bits will be 0. And the remaining I can do again valid words, and that is Mn minus 4. So final conclusion is this. Mn is equal to n plus 1, n equal to 1, 2, 3, 4. That you observed here, right? When n equal to 1, there are 2 vectors are there, n equal to 2, 3 vectors are there, 3, 4, 4, 5. So that I wrote here. When n is greater than or equal to 5, then I have mn equal to mn minus 4 plus mn minus 4. 1 plus mn minus 4. What is that I want to say? See, you have 0 first, right? I'm concentrating m5. How do you find m5? Right? All m5 we can easily figure out. So m5 is equal to, first you start with 0. So all these I can put. All these I can add. Right? That is that how many are there? So that is m4. So m5 is equal to m4 plus. Now the first one is 1, then next 3 are fixed, right? So it can be 0 also. This also allowed. That is exactly, there are 2 for here. So that is what I'm saying. Mn is equal to mn minus 1 plus mn minus 4. Is it clear? Any doubts? Rutuja, are you clear?
Yes, sir.
Okay. Now, once I have these formulas, now recurrence relation, right? You turn discrete mathematics maybe. So 5, what is the answer? M5 will be n greater than or equal to 5. That is M4 plus M1. Right? That is 7. Like that I computed. So 14 I'll get to 131. So answer is this final answer. Yeah. Before that, do you have any questions? Okay. X and Y are two binary vectors of length n. Then and their dot product is I. What is that I signifies? Okay. So for example, I have 1 0 1 1 1. Okay, x equal to this. Can you tell me why? Any y of length 5?
10101.
1 0 1 0 1. Okay. What is the dot product of these two? You know, right? How to do dot product. One into 1 plus 0 into 0 plus 1 into 1 plus 1 into 0 plus 1 into 1, right? What is the answer? You don't know dot product.
3.
This is 3. Why this is 3? So that is the question. That if the dot product, now I take two vectors of length n. Okay, so that the dot product is I. What is that I significant? What is this 3 telling about dot product? Simple question. Yeah, Pratik. Yes, tell me why it is 3. What is this 3 telling? Which one are contributing? Yeah, please. Okay, yeah. Rutuja, can you tell me?
Yes, sir.
So now I am telling you, I gave two vectors x and y. Okay, x dot y contains x dot y value is equal to 2. What is the meaning of that? In this example, it is 3, right?
The number of places that are contributing.
So when I'll get the number 2, to get 2, what is that I need to know about x and y? When I'll get it? Why I get 3 here? Which one is contributing 3 in this product? This is contributing, and this is contributing, right? Remaining are 0. Why? So in general, how do you know? That is the question I am asking.
So I is the minimum weight of x and y.
No, that is not. See,
Yes,
this
sir.
is coming when both the symbols are, when I am multiplying, both can be 1, then only I'll get it right. Are you following? Weight, I'm not talking about weights and all. Simply that total equal to 3 means at 3 places both have 1, right? Both are 0 also I'll get 0. Both one of them is 0 also I'll get 0. Dot product I am doing, right? So 3 means what? At 3 places they are both have, yes,
One.
ones, right? I'm asking very simple here, nothing. Okay. Okay, so I just want to ask you one. So can you give me 2 vectors of length 6 now? So that again we'll do one more time fast. Yeah, Pratik, can you give me one vector of length 6? Pratik, give me one vector of length 6. Okay. So Sonali, can you give me one vector of length 6 fast?
So 1 0 1 0 1 0.
1 0 1 0 1 0. Okay. Why?
1 0 0 0 1 1.
1 0 0 0 1 1. Very good. Thank you. Because if you give 0 1 0 1 0 1, then what is the dot product? If you give 0 1 0 1 0 1, then what is the dot product? 0, right?
Yes.
Not much useful. Okay, you gave nicely. Good. Thanks. See, I want to find dot product, right? For these two. Is it okay? I'll write this way. What is it I want to say? Okay, leave it that. Okay, what is it I want to say that? So how many positions they have common ones? I'll
2.
write 2 positions. What are those? This one and here, right? You know? Okay. So how many positions? So there are 2 positions. I is equal to 2, right? After multiplying dot product also you'll get 2 only, right? What is that I do? So in the first vector now, so I write these 2 ones before. Okay, remaining I will write. Remaining I will write 0 1 0 1. Are you okay? No, no. What is the time? So x and y pay. So I am bringing them first. Okay, first positions. So this I put. This is already in first position. That also I bring into second position. Remaining I will write as it is. So 0 0 1 0 and 0. Is it now dot product changes? These are new vectors, x tilde, y tilde, right? But is it both have same, these two dot product are same?
Yes, sir.
Yes, right? Yeah, that you understand? Yes, right? So what are these 2 positions? I positions, right? What is I? At I positions, they are the, both the places I have 1, right? In the remaining positions, okay, how many? N minus I positions, they are whatever. Okay, that is okay, leave it. Yeah, this is what I would just want to understand, want to help you so that the next questions becomes easy for you. Yeah, okay, nice. So if x and y are two vectors, Hamming weight of x plus y, okay, is even if and only if Hamming weight of both the vectors is even or both the vectors is odd. Okay, now I am coming to weight business. Okay, suppose I have two vectors of length n. Okay, x is of length n. That means there are m positions. Y is of length n, right? M positions again. And now I know weight of x equal to say b. Weight of y is equal to say, okay, I'll take rs. Okay. Now what is the weight of x, x plus y? I need to find out. My goal is to find weight of x plus y. So somebody can tell me. Is the question clear? I'll repeat again. Okay, I have two vectors x and y. Okay, I want to figure out what is x plus y. Okay, it is equal to how much? Okay, is it related to weight of x and weight of y like that? Okay, that is a question, right? So you look at this one now. So give me two vectors of length 5. So I'm now I'm taking. So yeah, what is x plus y?
0, 1, 1, 1, 0.
0, 0 here, 1 here, 1 here. Here also 1, right? And 0, correct? Yeah. So this sum is 0. This sum is 0. Remaining places I'm getting 1s. Yeah, good. I correct. Okay. So what is the weight of x plus? It is 3. What is the weight of x?
3,
3. What is weight of y?
4.
4. Is it somehow weight of, how do you find weight of x plus y? That is a question without actually knowing x and y properly. So weights of x and y are given. How do you find weight of x plus y? Actually computing x plus y. That is the question. Are you okay? So when weights will become? Weights will not come when
Both are ones.
both are ones. Okay. Also both are zeros also, correct? Yeah. But that is okay. Both zeros also fine. But so can you predict something now? When both are ones, you are not getting, right? Both are ones, you are not getting. But both are ones, how do you get? How many ones? Both the places ones are there. How do you know that? Hmm? Hello? How do I know that both the places may one hai? What is that? How do you get that number? How do you get both the places, both x and y have same ones? Number of positions. Number of positions, both x and y have same, both ones. So how do you get that? Yes, please. That is what I talked in the previous class. So previous problem, 8 pay. What is happening? If I find dot product, I'll get some number. What is that number tells? Hello? Okay, that is a number, right? So now here, these two positions I have ones. These two positions I have ones, right? So I'm putting them in the beginning. So x tilde, y tilde, 1, 1, right? Remaining I'll keeping as it is 0, 1, 0. So y tilde 1, 1, 1, 0, right? I keep like this. So, and again I can do one more. What is that I can do? So finally, what is it I want to say that you take a vector x, right? So I know both x and y. Both of them have dot product is there. Dot product gives the number of places. Both have ones, right? First, I'll keep those i's here. Then weight of a vector. Okay, what is the weight of this vector x? Hello?
3.
3. So wait. So how many ones still left now? Dot product of these two is 2, correct? So I put both of them here. So how many now ones will left in this x, right? One only left. That also I'll bring it below here. Okay, that also I'll bring here, right? I can put that one here. So those weights here, then all of them are 0. So what is this number now? So for example, dot product of x and y is equal to I, right? What is that I'm doing is, what actually I'm doing is that I'm changing now x to x tilde. How I'm changing, these are okay. So I'm putting now 1 here and the remaining 0, 0, right? Here I'm putting 0, 1, 1. Now we add them. Is the answer will change?
No, sir.
No. So what is that I want to say is that first I'll put I ones here. Here also y also I ones, right? And here how many ones I am putting now? Remaining. Total number of ones are weight of x, right? I ones are here. Now remaining how many ones left now?
Weight of x minus I.
Very good. This is weight of x minus y. Here there are some zeros are there and the last ones are ones here. How many ones are here? This is
Weight
y.
of y minus I.
Weight of 5 minus I. Correct. Okay. Now, so those are the things. Now, if I add them, so if I add these two vectors, now what is that I'll get here? This portion, I first I places.
Once.
No, here also once, here also once. Now I'm adding them. What is that I get here? 0, 0, right?
Yes, sir.
Yeah, here I'll get 0, 0, right? So, and here I'll get weight of x minus I once will come. Last पे weight of y minus I once will come because ऊपर पे 0 है नीचे 1 है. So add करते तो ये 1 ही आएगा. यहाँ ऊपर 1 है नीचे 0 है. So वो भी आएगा, right? So x plus y का weight क्या होगा अभी? So weight of so what is that I want to claim is this, okay? I explained that everything. So just I'll stop now with this. So you understand this. Weight of x plus y is equal to weight of x plus weight of y minus, yeah, what is the answer? 2 times weight of I, x dot. dot product, x dot product. Two times x dot product, x dot product y. Dot product y gives the number of common positions, right? So why this is so? See, these are anyhow 0. So weight of x plus y is weight of x minus I plus weight of y minus I, right? These are 0. So here the weight of x minus I ones will contribute. Below weight of y minus I, they also contribute. So total weight of x plus y is weight of x minus I plus weight of y minus I. So total answer is weight of x plus weight of y minus 2i. What is I? I is a dot product of those two. Okay, so this part is always even. So in order for x plus y is even, both vectors should be even or both should be odd. That is the answer. Okay, I'll stop with this.